Okay, gentlemen, today we're going to look at the sum and difference of cubes and learning to factor them. Okay, so if we remember from what we were doing right before the test when we were multiplying binomials by trinomials, so 2-term polynomials by 3-term polynomials, we were distributing the binomial into all 3 terms of the trinomials. Pretty much the binomial gets multiplied into every single one. So if we can look at an example, similar to something we've seen before, we first take the x and distribute it into all 3. And then we take the -2, don't forget the negative, and distribute that into all 3. If we multiply that out, we see we get x to the third for the first x in blue to the x squared. Then the x times the 2x gives me a 2x squared. And the x times the 4 gives me a plus 4. And then we just do the second term of the binomial into all 3. So the -2, x squared, -4x, and -8. What do we notice that happens? Well, the x squareds cancel and the x's cancel out. For this particular binomial times trinomial, we got those to cancel out and we just get the x to the third minus 8. That's our answer. So this is a very particular binomial times trinomial where that happens, where both middle terms, really all the middle terms, cancel out, and we only get the x to the third and the 8th. If you notice, x to the third is x to the third. 8 is what? 8 is 2 to the third. So these are both things raised to the third power, or in other words, cubes. So we're going to learn how to go backwards from that, just like when we learned what factoring was. Factoring was breaking up a product into its parts, just like we did with radicals. We break up the number in the radical into its parts, into its factors, making sure that they're prime. The prime ones stay in the radical, the pairs or the triples come out. Same idea here. We want to factor or break up a product into its pieces. Can we go from x to the third minus 8 to that binomial times trinomial? What's the pattern? How do we get there? Also, as a side note, that trinomial, so we know the binomial, x minus 2, that's prime. X squared plus 2x plus 4, the trinomial to the right, is that prime? In other words, can I break down that anymore? We now know how to factor trinomials. If we look, well, x squared plus 2x plus 4, I need two numbers that multiply to the 4 and add to the 2. Let's see. If I use 4 and 1, I'll never get to a 2, so that'll never work. Plus or minus doesn't matter, will never work. The only other way to get to 4 is 2 and 2, and that'll never get me to a 2. So there is nothing that can factor that trinomial. That will always be true when we factor cubes. Whenever we factor cubes, the trinomial next to the binomial, both of those are prime. Because if they were not prime, we would memorize the formula further. But we can't. We can't go any further than this. Okay, so we'll see some practice. And you'll notice every single trinomial I factor the cube into will not be factorable after that. All right, so here's our two formulas. If you notice, they're very similar. Both of them have a plus right before the b squared, like the last term squared. Always. That's always true. Now, the only difference is if you have a plus in the beginning, then you have a plus in the binomial, minus in the trinomial. Plus, plus, minus. If you have a minus originally, then you have a minus in your binomial and a plus in your trinomial. So it's either plus plus minus or minus plus plus. Okay, let's look at some examples. So first, we see this first one. Before I do anything, I always ask myself the same first question: is there a greatest common factor? For the first problem, we see that there is. There's a 2. So before I do anything else, I take out the 2. When I do that, I'm left with x to the third plus 8. Is that 2-term binomial? Are those cubes? Are they? We also know about dots. Could it be dots? Well, x to the third, not a square. We know that we can square root 8 and get that to work out, but x to the third is gonna mess it up. Plus, it's a plus sign. I need it to be minus sign, so it's not dots. The 2 stays there in front. I think I forgot to put that in the answer. But that can be broken down as an x to the third. And then plus, and then can I write the 8 as something to the third? Yes, that's 2 to the third. So we're now going to use, as our formula says, the x and the 2. The x and the 2. Because those are what my numbers cubed are, the x and the 2. So here is my first term. So first I do almost exactly as it is, x plus 2. I take the 2 cubes and I write them with plus. Now I start my trinomial. I'm going to write a minus sign, and then the last term is always plus. So I get my, according to my formula, a squared, so in this case, x squared. I'm going to write minus, then I get a times b, so x times 2. And then it's always plus, and then it's 2 squared. And obviously I simplify that, and I get x plus 2, x squared, minus 2x, we don't write x2, plus 4. The only thing I forgot to write was the 2 in front. There should be a 2 out in front here. Should be a 2 out in front here. I forgot that. And then as I keep going with this, it'll disappear. But we'll pretend it's there for now. Okay, next. 27 and the x to the third. It is minus, so we could think about doing dots, but it's x to the third. I can't do dots with x to the third. It has to be an x squared, difference of 2 squares. I can't do it with x to the third. So, can I write those as things cubed? Well, the first one's easy. That's x to the third. What to the third gives me 27? That's 3. And there's my minus sign. Now, with my minus sign, I know my first binomial is going to be those two numbers I just found, the x and the 3, with a minus sign in between them. Now, my trinomial, which again is not factorable, is going to be the first term squared, x squared. Then the first term times the second term, x times 3. And then we have plus, always plus is the last one, the last number we found, squared. Simplify that a little bit, x minus 3, x squared, plus 3x, plus 9. And again, if we look to try and factor the trinomial at the end here, two numbers that multiply to 9 that add to 3, there are none. And the one above, two numbers that multiply to 4 and add to negative 2, there are none. That'll never be factorable. Okay, let's look at the next one. 64, x to the third. Again, 64, oh, that's 8 squared, correct, but x to the third cannot do dots. It's x to the third. Even though 64 is 8 squared, can't do dots, and it's a plus sign. Definitely can't do it. X to the third, obviously, but 64 is also 4 to the third. And we're going to use our x and our 4. So, x to the third plus 4 to the third. So I'm going to do my x plus 4, plus plus. And then my trinomial is going to have a minus in it. X squared minus x times 4. Always plus 4 squared. So now we simplify it, make it nice and neat. X plus 4, x squared minus 4x plus 16. Okay, so there's kind of the first 3. And again, that trinomial at the end, there are no two numbers that multiply to 16 positive that add to negative 4. Okay, this next page, a couple little harder ones. Let's look through these, and then you have some problems to work on. First, 8x to the third. So there's a lot here, but can we take out a GCF? No, we cannot. 8 and 125 do not have any numbers in common. So can't take out a GCF. But can I do dots? Well, 8 is not a perfect square, but we know we can kind of deal with that. X to the third messes it up. It is minus, but 125 messes it up, not a perfect square. I do know, however, that 125 is a perfect cube, and I know that 8 is a perfect cube. And then obviously x to the third is a perfect cube. So I can take this and say, well, that's 2x to the third, 2 times x to the third. 2 times x times 2 times x times 2 times x would give me 8x to the third. My minus sign, and we know that that's 5 to the third. So sometimes you can't just have, you're not just going to have a plain old x in the front, just like we saw when we had difference of 2 squares with something like 25x squared minus 36, something like that. So now the numbers we're going to be using here are 2x and 5, not just x and 5. The 2's in there too. So let's be careful here. We have a 2x and then the minus 5. So the first binomial is always the numbers we just found, the perfect cubes we just found. Okay, now I'm going to get a plus in my trinomial, and it's going to be the first term I found, so 2x squared. Then it's going to be plus. Then it's going to be 2x times the second number, 5. Always plus the last term, 5 squared. Okay, a lot of students forget about the 2 in there, so let's be careful with that. Here we go, we simplify. 2x minus 5, 4x squared, plus 10x, plus 25. And if you wanted to try and factor this, you could, but 4 times 25, because we're doing A times C. There are no two numbers that multiply to 100 that add to 10. You're never going to find one. That is prime. Those two factors are prime. And again, think about it logically. If I could break it down more, why would we memorize a formula like this if we could break it down more? Okay. Next one. Two terms, x to the 6th and 125. Is it dots or is it cubes? Well, x to the 6th could go either way. I could say it's x to the 3rd squared or x squared to the 3rd. So technically, I look at this and I say, well, I'm not sure what to do, and it's minus. So I really am not sure. But the 125 tells me, well, that's a cube. I could write it as square root of 125, but it's kind of neater to write it as my cubes, right? Because I know 125 is 5 cubes. So there's my x squared to the 3rd. That's how I can represent x to the 6th. And then there's my 5 to the 3rd. It's much nicer to write it like that. Again, I could say, technically, square root of 125 and just leave it as dots like that, but this one's a little bit neater. You would not be wrong, technically, if you wrote it that way. But it's nice to see that 125 is a cube, so here we go. I'm going to use my x squared and my 5. X squared minus 5. Next one's going to be plus in my trinomial, x squared squared. Here's my plus. X squared times 5. Again, always plus 5 squared. It's my 120. It's going to be my 25. So there's my x squared minus 5. X squared squared, that's x to the 4th, plus 5x squared, plus, there's my 25. Okay, so keeping in mind dots or cubes, that's a question we're going to see a lot because it is always two terms. I mean, you want to recognize, are my terms squares or cubes? Sometimes you can go both, sometimes one way is better. Again, here, dots or cubes. Well, again, the same question, x to the 3rd squared or x squared to the 3rd. It's either going to be something cubed or something squared. I look at my 81, that's a perfect square. It's not a perfect cube. I can't even do the formula. So I'm going to just do regular dots here. X to the 3rd squared and 9 squared. So dots is very simple. 2 parentheses. X to the 3rd in both, 9 in both, one's plus, one's minus. And there's my answer there. Again, just to reiterate up above, I just wanted to fix my mistake. There is a 2 in front of the first one that I forgot to add in. Make sure we add that 2 in there. When I GCF'd it out, I forgot to put it back in. Okay, but again, all these cubes, difference or sum of cubes, are written as a binomial times a trinomial. The trinomial cannot be factored anymore. And again, we see sometimes we have a choice to make with cubes or dots, and just look for the easier one. Either the numbers are cubes or squares, and that's always the easier one. Okay, so you're going to have a couple problems to do for your async assignment. Good luck.